Okay. So the first unit we're going to be covering is number sequences. And so we're going to be looking at specific types of patterns and predicting what would be the, I don't know, 98th term in a pattern, or figuring out what something called a common difference or the common ratio is. So we're only going to study particular patterns. We don't actually cover sequences that don't have a pattern. They're not very interesting to look at. You would call the first term in the sequence term 1, right? T1 or term 1. T2 would be your second term, T3 is your third term, and so on. That's how we label our terms. So the very first sequence, did you figure out what was going on? Each time, what were we doing? Subtracting 3. We were subtracting 3 each time. So negative 8, next would be negative 11, negative 14, and negative 17. So we're subtracting 3. So that's a very specific type of sequence. It's actually called an arithmetic sequence, because we were subtracting 3 each time. What was happening with the next guy? Multiplying by 3. 27 times 3 was what? 81, then, and 7. Perfect. And so that also has a very specific name. We call it that a geometric sequence. Okay, so when we are adding or subtracting something every time, it's arithmetic. If we are multiplying or dividing, it's geometric. So arithmetic is when you add or subtract the same number each time to get to the next term, and geometric is when you multiply. And you can think of it as division too, multiplication or division. Usually we only think of it as division. So what I mean by that, is multiplication. So if you're dividing by 4 every time, that's the same thing as multiplying by what? If I'm dividing by 4, it's the same thing as multiplying by 1/4, right? Dividing by 2 is the same thing as multiplying by 1/2. Dividing by 3, multiplying by 1/3. It's the same thing. Okay, so usually we think of it in terms of actual multiplication instead of division. The next guy, what's going on? You are, again, that's so boring, sorry, subtracting 3 again. So we're at -1 and -7. So again, this would be what we call arithmetic again. Okay. What's going on with the next guy? Did anyone figure it out? Yep. Close. Wrong word. Instead of 2, you call it something else. Yeah. Oh. So I see what you're saying. You're saying you added 3, then I added 5, and then I added 7. And then you'd add 9. I guess that would work. Did anyone else figure out another way? Yeah? Okay, so then what'd you get for your next term? After 16? 25, then what'd you get after that? 46? 36, and then 49. Yeah. There's another way to think of these numbers. What are they? Perfect squares. Yeah, so these are perfect squares. So yeah, you could think of it as adding 3, then adding 5, then 7, then 9, then 11, right? That works too. And 13. Cool. But they're perfect squares too. Does anyone know what this last sequence is called? Fibonacci. The Fibonacci sequence. So what is the Fibonacci sequence? Don't know, but you knew the name. That's impressive. Yeah? The last two numbers and you add them together to get the next one. So 1 and 1 is 2, then 1 and 2 gives you the 3, 2 and 3 gives you the 5, and so forth. So what would be the next term then? 5 and 8, 13, 13 and 8, 21, 20, and 34. Good old Fibonacci. So we're just going to focus on arithmetic and geometric sequences this year. No fun sequences like Fibonacci. Okay, so as mentioned prior, oops, what happened here? Let's fix that. A sequence can be described as by a general mathematical equation. And that general mathematical equation is what we call the general term. So for example, if I had a sequence that was 5, 7, 9, so forth, I could come up with a general formula that can help me get each term. So 2n plus 3, where n is your term number. So for example, term 1, if I put n as 1, 2 times 1 plus 3 would give me 5. If I put in term 2, n is 2, 2 times 2 plus 3 is 7. I put in 3, right? So we can make up, when we have arithmetic or geometric, we can actually make a general term, a formula, so that we can get any term in the sequence. And so the general term is actually it's a formula. It's general. I can use it to get any term. That's why it's called general term. So sequences can be arithmetic when we're adding something every time. So for example, 2, 4, 6, 8. Okay? Because you're adding 2 each time. Or geometric would be 2, 4, 8, 16, 32. What am I doing in the second one? Multiplying by 2 versus adding 2. Okay? So that's the difference between arithmetic and geometric. All right, which one would I call term 1 is in this example, the first example here? Would be 4. Term 2 would be 8, then 12, and 16. So figure out term 8. What'd you get? Did you get 32? Okay, so if I asked you for term 100, this method, just figuring out one at a time, would be very cumbersome, right? That's why we want to develop a formula or general term, because if you want something higher than, say, term 8, it starts to get really tedious trying to figure out every term to get the next. Now, is this one, what's going on with each term? What are we doing each time? We're adding 4, so we would call this arithmetic or geometric? This is arithmetic. Okay, so let's do the next one. Term 1 would be 1, term 2 would be 2, term 3, 4, term 4 is 8, term 5 is 16. So figuring out term 8, what would be term 6? 32, term 7, 64, so term 8 would be 128. What are we doing each time? Multiplying by 2, so this would be geometric. Okay? So, if I'm asking for t at n, that's the value of the nth term. It's also what we call the general term. Just a side note. So T1 is the value of the first term. T5 is the value of the fifth term, right? That's what that means. Okay, let's look at the next page. So we're going to specifically focus on arithmetic for the next 3 classes, and then we'll start geometric. So arithmetic sequence is a sequence with a constant difference or common difference between consecutive terms. So it's also known as common difference or constant difference. What does it mean, consecutive terms? Consecutive. One after the other. So for example, term 2 and term 3 are consecutive. Term 3 and term 4, consecutive, one after the other. Okay, those are consecutive terms. So we denote the first term as T1. We denote the common difference, what we're adding and subtracting. So the common difference is what we're adding and subtracting each time. So this very first sequence, what would be the first term? T1. 3, and what would be the common difference? 2. We're adding 2, so it's positive 2. If we were subtracting 2, it would be negative 2. Okay, T1 in the second one would be 100, and what's your common difference? Negative 3, because we're subtracting 3 each time, it's minus 3. Next guy would be 5 and 120. We're adding 120 each time. Good. So figuring out what your first term and common difference is going to be really crucial to figuring out the formula, the general term, okay, coming up. So first thing I want to talk about is we can represent arithmetic or any sequence different ways. One is you might see it as a graph. So it might show up on a graph as on a test. Okay, so if I graphed a sequence, your x-axis would be your term number. And then your y is your t of n, the actual term, what it is, the value. So what's the actual value of the term? So when I plot this, the first point, it's not the greatest graph, sorry. When your n was 1, this is term 1, the value is 2. Okay, so I'd have a point at 1, 2, I guess, so the coordinate 1, 2. So when n was 2, term 2, what's the value of it? 4. Okay. When n is 3, term 3 would be 6. Term 4, 8. Okay. So notice that the data is going to be discrete data. Do you remember that from 10C? The graph will be, what does it mean to be discrete? I don't know if that's how I describe it. Yeah? You don't take the data between the 2 points. Yeah. So, like, does it make sense to have half of a term? No. Or 2.5, 2.7 term. It doesn't make sense. N is always an element of the natural numbers. Okay? So natural numbers, does anyone remember what the natural number system was? Not whole, because there's a difference between whole and natural. They're similar. Whole actually includes the whole. Includes 0, right? Natural numbers are the first numbers you learn when you were born. You learn to count, you start at what number? 1. They're counting numbers, excluding 0, right? Because you don't count with 0. So natural numbers are 1, 2, 3. And so n is always going to be a natural number, and so we don't connect the data. And it would look like that. What else do you notice about this graph? Anything? Linear. Okay, that's very important. Arithmetic sequences, because we're adding the same thing each time, that's like our slope. It's increasing at a constant rate of change. Arithmetic sequences are always linear. So just by seeing a linear graph, you know it's arithmetic. They have a constant rate of change. can use it words. That's very like junior high. We won't use words. We want to get into like the equation. There's also something called a recursive formula. So a recursive formula, you'll see that more if you take university math. And recursive formulas rely on knowing the previous term. So it relies on knowing the previous term. So a recursive formula, in this case, would be our t of n equals t of n minus 1, the previous term. And what are we doing to each term each time? We are adding 2. So the previous term plus 2. So that would be the recursive formula. I would also need to know that term 1 is equal to 2. I have to know where I start, right? Because you have to know at least one term in order to make a recursive formula. So I know that the previous term plus 2 is equal to the next term. You have to start, where do I start? So you have to know term 1, okay? So, and then you can use that. So term 2 is term 1 plus 2, term 3 is term 2 plus 2. That would be your, like this would be the recursive formula. Again, we're rarely going to see that because they're like very tedious. If I want the 100th term, I need to know the 99th term. If I want the 99th, I need to know the 98th. So again, not very helpful. Oh, so can we come up? Ooh, sorry. Let's fix this. Uh-oh. What happened? Again, I did it again. There we go. Sorry, guys. I'm having issues today. There it is. Okay, so if we thought as x was your n and y was t of n, right? When term 1 was equal to 2, term 2 was equal to 4, term 3 was 6, 4 was 8, right? Am I right? No, did I get that wrong? Term 1 was 2, right? Yeah, and 4 was 8. Good. Oh, stop moving on me. Now extend the page there. Okay, so can we come up with a formula? What's the relationship between our x and our y? What are we doing to the n each time? Multiplying it by 2. So we can make our formula. T of n is equal to 2n, 2 times the term number. So for term 3, let's double it, you see 6. And 4 was 8. Okay, so that would be your general term. All right. So we just need to get to the end of this page for today. And the rest of the lesson we'll go through tomorrow. How are we doing? We're okay. Okay, not done. 1, 2, 3, 4. So to get from term 1 to term 2, if it's arithmetic, we're adding a common difference. And each time to get to the next term, we're going to be adding the same common difference. Right? So you can think of your first term, well, we just would call it term 1. The second term is the same thing as term 1 plus 1 common difference. Make sense? Term 3, it's the same thing as term 1 plus how many common differences? 2 of them, right? Term 4, I would be adding my common difference how many times to term 1? 1, 2, 3. Okay? And so forth. So notice that if term 1 was term 1, term 2 was 1 common difference, term 2 or 3 we added 2 common differences. Notice it's always 1 less than the term number, how many times we're adding the common difference. And so that's where this formula comes from. Your t of n, any term, is equal to the first term plus 1 minus the term number to figure out how many times you're adding your common difference. So the fourth term, we added the common difference 3 times. So 4 minus 1. The fifth term, we're adding the common difference 4 times. 5 minus 1. So that's where the minus 1. How many times are we adding the common difference? And that's our formula we're going to use for arithmetic sequence. Okay? So when I ask you to find the general term, we're looking at the formula. This is on your formula sheet. Okay. So if the formula is t of n equals term 1 plus n minus 1 times the common difference. There's two things we need to know to make the general formula. First term and common difference, which is why we listed them earlier. What's the first term? 8. What's the common difference here? 4. We are adding 4 each time. Right? That is the common difference. So we're going to plug those two things into the formula to make the general term. Stop moving. Sorry. Okay. Stop doing that. Sorry, guys. First day, and it's already making me angry. We're not replacing the n because we want to leave n blank. We want it general so we can figure out any term number. And so that's going to stay as just t of n and n. We're not replacing those two. Term 1 is equal to, you said 8 plus n minus 1 times 4. Okay. Now that's kind of ugly. So we're going to simplify this. How can I simplify this? Any ideas? What's this called? A little bit backwards. Distributive property. Remember that? So we want to bring the 4 in. It's kind of weird having a binomial times a monomial. It's usually the other way around, but it's fine. So let's distribute that 4 in. And we're left with t of n equals 8 plus 4 times n. 4n, 4 times negative 1. Negative 4. Collecting like terms. We have 4n plus what? 8 minus 4 is 4. So there's your general, that's a general term. And you can check to see if you're right. Plug in n is 1, is 4 times 1 plus 4 equals 8. Yeah. Term 2, 4 times 2 plus 4, 12, yeah. Okay, so you can check to see if you had the right formula. Just sub in your n values. So now, finding term 20, a breeze. We can sub it into our formula. So term 20 would be 4 times 20 plus 4, which is 4 times 20 is 80 plus 4, 84. Okay, now you could have also plugged it into this formula if you wanted to. That's fine, but normally we'd want to simplify it and just use our simplified form, right? So if we did that, I'm just going to show you something for a second. 8 plus, it would have been 20 minus 1 times 4. So that makes sense because you start at your first term of 8, and we're adding 4 19 times. So that's what that means. So we started our first term. If I want the 20th, I have to add the common difference of 4 19 times. And that also gives you 84. It's the same thing. So you can use either formula. Oh, do you want to try the next one? No? Yes? You ready for that? You should get your common difference of 3 and our first term of 12. Plug it into the formula. Distribute the 3 in. So 12 minus 3 is how you get 9. 3n minus 9, or plus 9, sorry. So that would be the general formula. And then figuring out term 10, I can either plug it into here, 3 times 10 plus 9, 39, or plug it into here, 12 plus 10 minus 1 times 3. So the 10th term, we're adding 9 3's to the very first term, which gives you 39 as well. Okay. I just wanted to add a little thing. So T of n, if you just look at the top here. So T of n, we think of that as the term we're looking for. It's often also thought as the last term. The term we are looking for slash the last term. Okay, it's often thought as the last term. Can you read that? Make it a little bigger. I don't know how big. Nope. 200. Okay, so the term we're looking for is also thought as the last term. Because what if we know the last term and we're looking for what term number that is? Obviously, this is equal to the first term. Okay, plus the n minus 1. That's how many times, the number of times we add the common difference. Okay, and what's D? Times the common difference, right? First term plus number of times we add the common difference times the common difference. And that will give you your term you're looking for or the last term. So one more question. And then we're going to leave. That's where we're going to call it quits for the day for as far as lesson goes. How many terms are there in the following sequence? Okay. So tell me what you know here. Yeah. Okay, you know T of n, which is 152. So you know the last term, the very last term. Because when it's asking for how many terms, they're looking for n. N is defined as the term number. So we want to know what term number is 152, and that will tell me how many terms we have. And so 152 is our last term, is our T of n. We don't know what n is. That's what we're looking for. What else do we know? Okay, something's wrong with this. Okay, term 1 is -3, and what's the common difference? 5. Adding 5. So we can sub it in to our good old arithmetic formula. For any arithmetic sequence, this formula works. We're going to replace T of n with 152. Our last term equals, what's our first term? -3 plus, do we know what n is? No, that's our unknown, and our common difference is 5. Okay, so we need to solve for n. Where would I start with that? Distribute, yeah. Distribute the 5. I like to put the common difference in brackets because if it's a negative, like I haven't given you an example like that, but if, say it was a negative, so let's just make something up, 6 plus n minus 1, and your common difference was -2. Okay, there's a difference between that and that, right? This means multiplied by -2. This means subtract 2. So I like to get in the habit of always putting my common difference in brackets, because if you were to write it like this on a test, you would lose marks. Because we are multiplying by -2, not subtracting 2 if your common difference was negative. So that's why I always throw this last number in brackets. It's a good habit to get into because if it is negative, you're not going to lose marks. Okay, sorry, side note. Negative 3 plus 5 times n. 5n minus 5 times negative 1 is minus 5. So let's calculate terms first. I have 5n minus 8. Okay, what's next? Solving a linear equation. We did this lots in junior high. And even in 10C, yeah. Add 8. So we want to get n by itself. So first thing, let's get the constants together. And then divide by 5. Which goes in how many times? 32? So that means there's 32 terms because the 32nd term is 152. Okay, so that's where we're going to leave it for today. On the very front of the book, it tells you the assignment for today, which was, what was it? I have it here. So you're going to need a textbook at this point. You're welcome to use the math website. Page 16 to 20, numbers 1 to 5. Should be quick, but you're probably finishing class today, which would be a nice start to the so at this time, if you'd like to quickly go to the library and get your textbook, you're welcome to do so. Otherwise, you can use your cell phone or whatever. Let's get to work, okay? Listen to music? Sure. Yes. As long as you're not playing games on your phone, right? Like using it as a distraction, music's fine. Your textbook. So you need a textbook. So if you did not get it yet, you can go quickly to the library. Okay? So go to the library and sign one out. Near front, okay. So front and front. Okay. If you need the friends right here, come over. Procure it.